we present a visual analytics system for efficient image exploration and user-guided image captioning. The system contains three main components. The co-occurrence graph view uses a node-link diagram to present the dominant and co-occurred features within an image dataset, providing a holistic overview of the dataset. The image segment wheel presents extracted image segments in a scatter plot, where the points can be colored to reflect their received attention or word coverage. The interactive caption wheel provides two ways for users to engage with a caption model and steer the captioning process. Let's now walk through a case to show how the system works. First, we select the Tench class from the ImageNet dataset. The co-occurrence graph then presents the node-link diagram built on top of the captions generated from all Tench images. Dragging and dropping each node will pin it at a fixed position. This function is very useful for users to track and locate the node of their interest. The force-directed layout algorithm will also update the position of other nodes accordingly. Clicking a node or directly typing a word will select the node, showing the corresponding feature's frequency. This will also update the color mapping of the scatter plot, reflecting how strong the word attends to different image segments. From the interface, we can also specify the ITM score range based on the score distribution. The outer ring of individual nodes will be updated accordingly to reflect the portion that a word is within the selected range. In this case, most of the ITM score are large, indicating the good captioning performance of the blip model. Coming to the image segment wheel, if no word is selected, the scatter plot will be colored based on the coverage of individual segments, and we can use lasso selections to explore different segment clusters. For example, the green clusters are segments that are well covered by the captions, and we can easily verify that those clusters represent fish, man, and night, respectively. The yellow points are segments that are not well covered by the captions. If the yellow points are scattered, they may represent some fragmented features. However, if the yellow segments form into isolated clusters, it usually reveals a common feature that is not covered by the captions, which could be a weakness of the captioning model. For example, this cluster is for the hat segments. This cluster is for hair segments. This cluster is for tree branches. This cluster is for background water. And this cluster is for the sky segments. All those features are not well covered by the captions. Some of them are indeed less important, but some may be of special interest of the users. When the word is selected, the color map of the points will be changed to reflect their attention with the corresponding word. For example, this cluster responds strongly to the word net. These three clusters respond strongly to the word man. These two clusters respond strongly to the word fish. This cluster also strongly responds to the word large and holding, which explains why the cluster has a large word coverage. We can do the lasso selection again, and the segments will be overlaid with a heat map, showing the spatial distribution of the attention over the segment pixels. Clicking individual point will show the corresponding segment, the image that the segment belongs to, and the generated captions. Words that strongly attend to the selected segment are colored with yellow background. Clicking the image will select it into the interactive caption wheel, where users can steer the caption generation process. In this wheel, users can tap the starting prompt and use it to generate new captions. For example, when changing the prompt from "a picture of" to "the man is wearing," we successfully get the model to generate the word hat in the resulting caption. There are also cases that the starting prompt cannot work very well. For example, in this case, the model generates the word headphones in response to the word wearing in the prompt. In order to more explicitly tell the model what features we want, we can directly click the head region and increase the weight of the corresponding patches. When we increase the weight to 1.5, we can see both red shirt and white hat appear. When we keep increasing the weight to 2, we can see only the white hat is in the generated caption, as the corresponding patches dominate the image content. More exploration cases with different classes of images have been included in our paper and appendix. Please check them for more details. Thank you for watching.